Mendeleev's periodic table. Mendeleev, a Russian chemist, while trying to classify elements, discovered that on arranging in the increasing order of atomic mass, elements with similar chemical properties occurred periodically. In 1869, he started this observation in the following form, which is known as Mendeleev's periodic law. A periodic function is the one which repeats itself after a certain interval. Thus, according to the periodic law, the chemical and physical properties of elements repeat themselves after certain intervals when they are arranged in the increasing order of their atomic mass. A tabular arrangement of the elements based on the periodic law is called periodic table. Mendeleev believed that atomic mass of elements was the most fundamental property and arranged them in its increasing order in horizontal rows till he encountered an element which had properties similar to the first element. He placed this element below the first element and thus started the second row of elements. Proceeding in this manner, he could arrange all the known elements according to their properties and thus created the first periodic table. The horizontal rows present in the periodic table are called periods. Properties of elements in a particular period show regular gradation, that is, increase or decrease from left to right. The vertical columns present in it are called groups. Groups 1 to 7 are subdivided into A and B subgroups. Group 8 don't have any subgroups. All the elements in a particular group are chemically similar in nature. Mendeleev's was the first classification which successfully included all the elements. Mendeleev's periodic table had some blank spaces in it. These vacant spaces were for elements that were yet to be discovered. For example, the element gallium was discovered 4 years later and its properties matched very closely with the predicted properties of Eka aluminium. The modern periodic table. Henry Moseley, an English physicist, discovered in the year 1913 that atomic number is the most fundamental property of an element and not its atomic mass. Atomic number Z of an element is the number of protons in the nucleus of its atom. The number of electrons in the neutral atom is also equal to its atomic number. This discovery changed the whole perspective about elements and their properties to such an extent that a need was felt to change the periodic law also. After discovery of atomic number, the periodic law was modified and the new law was based upon atomic numbers in place of atomic masses of elements. The modern periodic law states the chemical and physical properties of elements are a periodic function of their atomic numbers. The periodic table based on the modern periodic law is called the modern periodic table. Many versions of this periodic table are in use, but the one which is most commonly used is the long form of modern periodic table. Now let us learn the main features of this periodic table. There are 18 vertical columns in the periodic table. Each column is called a group. Group 1 on extreme left position contains alkali metals Li, Na, K, Rb, Cs and Fr. And group 18 on extreme right side position contains noble gases He, Ne, Ar, Kr, Xe and Rn. There are 7 rows in the periodic table. Each row is called a period. The first period is the shortest period of all and contains only 2 elements, H and He. The second and third periods are called short periods and contain 8 elements each. Fourth and fifth periods are long periods and contain 18 elements each. Sixth and seventh periods are very long periods containing 32 elements each. Periodic properties. The properties that repeat at regular intervals are called periodic properties. Important periodic properties are atomic radius, ionization energy, electron affinity, electronegativity. Atomic radius is the distance from the center of the nucleus to the valence electron in an energy level. Atomic radius is expressed in angstrom units. The atomic radius decreases across a period and increases down the group. Fluorine has the smallest atomic radius of 0.72 angstroms units, while cesium, Cs, has the highest atomic radius of 2.62 angstrom units. Ionization energy is the minimum energy required to remove the outermost electron from a gaseous neutral atom to form a cation. The unit for ionization energy is electron volts or kilojoules per mole. Ionization energy increases across a period. Ionization energy decreases down the group. Helium has the highest ionization energy in the periodic table, while cesium has the lowest. The energy released when an electron is added to a neutral gaseous atom is known as electron affinity. The unit for electron affinity is kilojoules per mole. The electron affinity increases across a period while it decreases down a group. The tendency of an atom to attract the shared pair of electrons towards itself is known as electronegativity. Electronegativity increases across a period while it decreases down a group. Atomic size. Atomic size is the distance between the center of the nucleus of atom and its outermost shell. It is also called atomic radius. Unit of atomic radii is A. Angstrom unit 1A star is equal to 10 to the power minus 10 m. Atomic size depends on two factors. 1. Number of shells. 2. Nuclear charge. Number of shells. Increase in the number of shells increases atomic size as distance between the outermost shell and nucleus increases. Nuclear charge. Increase in the nuclear charge of an atom decreases atomic size as the electrons in the outermost shell are attracted towards the nucleus with a greater force. You will see that the atomic radius decreases in moving from left to right along a period. This is due to an increase in nuclear charge, which tends to pull the electrons closer to the nucleus and reduces the size of the atom. The atomic size increases down the group. This is because new shells are being added as we go down the group. This increases the distance between the outermost electrons and the nucleus so that the atomic size increases in spite of the increase in nuclear charge. Earlier attempts of classification of elements. Dear students, you all must have gone for shopping. You might have seen that soaps are kept together at one place while biscuits are kept together elsewhere. Even among soaps, bathing soaps are stacked separately from washing soaps. You must have visited a library. There are thousands of books in a large library. In spite of this, if you ask for a particular book, the library staff can locate it easily. How is it possible? In library, the books are classified into various categories and subcategories. They are arranged on shelves accordingly. Therefore, location of books becomes easy. The earliest attempt to classify the elements resulted in grouping. These elements were known as metals and non-metals, but some elements showed properties of both metals and non-metals, and they could not be placed in any of the two classes. After this, scientists made attempts to recognize some pattern or regularity in variation of properties of elements and to classify them accordingly. Now we shall learn about some of them. In 1829, Dobereiner, a German scientist, made some groups of 3 elements each and called them triads. All 3 elements of a triad were similar in their properties. He observed that the atomic mass of the middle element of a triad was nearly equal to the arithmetic mean of atomic masses of other 2 elements. For example, take the triad consisting of lithium Li, sodium Na and potassium K with the respective atomic masses 6.9, 23.0 and 39.0. Mean of the atomic masses of the first Li and the third K elements 7 plus 39 upon 2 is equal to 23U.